Hello, everybody. We're going to be talking about hybrid circuits in this one. And to start off, I have a simple parallel circuit. All right, so let's go back to the ideas of parallel circuits again. So we have 24 volts dropping across this. And again, the logic is that if I look at this dot here, this red dot, and I go over to here, this would be at the same potential. So would this, and so would this. The reason being that there's no resistance between any of these dots. Similarly, if I look at that green one, it's at the same potential as this end and same potential as these because there's no resistors between these. Therefore, if there's 24 volts potential difference between these two dots, it makes sense that there's 24 volts 24 volts potential difference across these two, and 24 volts potential across these two. All right, so I know that it's going to be 24 volts here. I could fill that in and solve this. However, whatever I get for the currents, I would have no way of checking. So we always do with this a redraw. So let us proceed and do a redraw of this circuit. Now I'm going to replace these with a single effective resistor that would equal their two resistances in parallel. Well, what are the ideas here? If that's an 8 ohm resistor and that's a 12 ohm resistor, for my effective resistance, I know that if I cut this off, it's already 8 ohms. And if I open up some other way for electrons to get through here, it cannot increase it more than 8 ohms, but rather it has to decrease it. So my overall effective resistance has to be less than 8 ohms. But also imagine, if this was also another 8 ohm resistor, I would make it twice as easy for the current to get through or give a resistance of 4 ohms, which means, in this case, it would be logical to realize that the overall effective resistance has to be less than 8 ohms and more than 4 ohms. This will keep me from making some of those common silly head mistakes that we tend to make on problems like this. So, the formula is 1 over the effective resistance equals 1 over the first resistor plus 1 over the second resistor, and so on. However many resistors you have, you keep taking their reciprocals, adding them together, press equals, and take the reciprocal of that. Making sure you understand the logic of that it has to be less than 8, more than 4 will keep you from the most common error, which is just putting down the reciprocal instead of the actual. So we take this, we say 8, 1 over x, plus 12, 1 over x, equals, hit 1 over x one more time, I get 4.8 ohms. Now, does that satisfy my requirements? Yeah, less than 8, more than 4, excellent. So, the 24 volts, 24 volts is dropping over this entire thing. I, the current, equals voltage divided by resistance. So I can see that 24 volts divided by 4.8 ohms, that equals 5 amps. Excellent. All right. Now I know what the currents should equal from both of these, and it allows me to check my work. I know it's going to be 24 volts over both of them. Now, once again, I equals V over R. So 24 volts divided by 8 ohms gives me 3 amps. Similarly, 24 volts divided by 12 ohms gives me 2 amps. And I can see, looking at this, that they both equal the total of 5 amps that I predicted I would get here. So I know I have done this correctly. I checked my work. Life is good. But what happens if I were to put a resistor in line with that? So let's try that right here. So we'll come up with another one. 24 volts. It's going to be exactly like the first. And now I'm going to put a 3 ohm resistor in here. And I will put the 8 ohm resistor I had previously, as well as the 12 ohm resistor I had. We know what the effective resistance of this is already. So I have a 3 ohm resistor, 8 ohm resistor, and a 12 ohm resistor. Wonderful. So, before I can proceed and start filling all this in, I need to do not just one, but 2 redraws. So, redraw number 1, I take this circuit, I have the 3 ohm resistor there, but now I replace both of these with a single effective resistor that would be the same resistance as the 2 of them in parallel. So 3 ohms. Well now, if I have the 8 ohm resistor, I'm doing this again just so you can see, 8, 1 over x, plus 12, 1 over x equals, don't forget to hit 1 over x one more time, and don't forget to look at it and know that it has to be less than 8, more than 4. So we have 4.8 ohms. All right, but I still can't solve this. I need to do a redraw number 2. And in my redraw number 2, I'm going to replace both of these with the rule of series circuits. And I'm going to see that 3 ohms and 4.8 ohms is 7.8 ohms. We have 24 volts. So I know that 24 volts drops completely over that. I equals V over R. So I have 24 volts divided by 7.8 ohms. So I have 3.1 amps going through that. So from this, what numbers can go up here? Well, that 3.1 amps, that could go up here, right? The voltage drop, the voltage is going to split up dropping over these. So 3.1 amps is going through that, and 3.1 amps is going through that. Now, V equals I times R. So I'm going to take this number and store it so I can use it, not the 3.1, but the actual number. So this times my 3 ohms equals 9.2 volts, and recall times 4.8, that is 14.8 volts. So 14.8 volts and 9.2 volts, so plus 9.2, that equals about 24 volts. So I know I have done this correctly. It's just up to the last step. So I am done with this 3 ohm resistor. Everything goes right here. 3.1 amps, 9.2 volts. Life is good. But from here, what comes over? Can I put the current here? Well, no, because the current splits here. Some goes one way, some goes another. But the voltage drop by 14.8 volts, that is the same in both cases. So then I now can find my current, and my current needs to add up to my 3.1 amps. So I equals V over R. So we have 14.8 volts divided by 8 amps, 1.8 divided by 8 ohms, gives me 1.85 amps. 14.8 volts divided by my 12 ohms is 1.23 amps. And when I add that together, 0.85, I end up with my 3.1 amps, which is what's going all through that. So there's multiple ways to check this, multiple ways to be sure you have gotten it quite correct. And that is how you do a hybrid circuit. Let's do one more. Let's make up a more challenging one, shall we? Well, of course. All right, so I'll throw as many curves as you're likely to ever see in this. We'll have a resistor up here. We'll break it into two resistances down here. On the parallel leg, and why not, just for fun, do one more resistor here. All right, so we have a 4 ohm resistor here. How about a 7 ohm here, 11 ohm here, and a 13 ohm resistor here, and power that with a 20-volt battery. Okay, so we want to do an RD number 1, and that will be getting rid of the parallel. So we'll have the 4 ohm. We'll replace the resistor here. All right, hang on 1 second while I get some light back in this room. There we go. All right, so what do we have? Well, we have a 4 ohm in line with a 13 ohm. And what do I do for these? Well, before I even do it, I know it has to be less than the lowest value. And because there's two resistors here, cut that 7 in half. So it has to be less than 7, greater than 3.5. That will let me know if I'm doing it correctly. So 7, 1 over x, plus 11, 1 over x equals. Well, if I were to leave it there, I know that it can't be that. It has to be greater than 3.5. So it might have reminded me then that I need to press that one more time. 4.3 ohms, well, that satisfies. Less than 7, greater than 3.5. So we have 4.3 ohms. Not done yet. I could put my lines for solution in. And now my RD number 2. Label these things so as not to get so lost. Now I'm going to replace all of these with a single effective resistor, still on 20 volts. Now, what would that single effective resistor be? Well, this value plus all the other resistors, because now I'm just in series with them. So I would have a 21.3 ohm resistor. I know that 20 volts is dropping over the entire thing. So I equals V over R gives me 20 volts over 21.3 ohms. Should be a little less than 1, and it is. It's 0.94 amps. Great. Well, now what can I do with that? Well, all that current must be going through each of these resistors. So I have 0.94 amps, 0.94 amps, 0.94 amps. I will remind you again, to do proper physics stuff, we don't want to make these silly mistakes. And we tend to make the silly mistakes if we start getting careless. So this is not 0.94 amps. It is 0.94 amps. That's the way you report it. The 0 is important in front of the decimal so we don't miss the decimal. Decimal is a tiny little dot, very easy to miss. When you're doing so many calculations, you can't trust that your memory will hang on to something like that. So it's 0.94 amps. While we're doing it, do it right. All right, so we know that voltage equals current times resistance. So I'm going to store this, and that times 4, that gives me a voltage drop of 3.76 volts. Recall 1 times 4.3. That gives me a voltage drop of 4.04 volts. I'll bring the scientific, I'll bring the numbers out a little bit further here. And recall 1 times 13 ohms gives me 12.2 volts. This is all on the 20-volt circuit. So before I go further, how do I check to make sure that I've gotten this? 12.2 plus 4.04 plus 3.76. Look at that. Comes out to be 20 volts. Wonderful. So I am done with this one. I just could put the numbers right in. I'm done with this one. I could just put the numbers right in. 0.94 amps, 12.2 volts. This is 0.94 amps, 3.76 volts. This one, now what do I have? Well, I can't say what the current is because some of the current goes this way, some of the current goes this way. However, the voltage between these 2 points, I do know that. That is 4.04 volts. 4.04 volts. And if I equals V over R, I could take my voltage, 4.04, divided by my resistance. I should have 0.58 amps. And over here, 4.04 voltage divided by resistance divided by 11 equals 0.37 amps. And I will just add those together very quickly, plus 0.58. And that, you will see, comes out to approximately equal the 0.94 amps that I had to begin with. So I am done with this. I have checked it, and it works. And you can see, you don't need me to go over this for you. You could make up your own problems and share them with your friends. All of you see if you can solve this. If you could do a hybrid circuit, you could do a parallel circuit, you could do a series circuit in your sleep. And if you could do a hybrid circuit, you might just start to find out that this is kind of fun. It's a puzzle, and it's a puzzle that you can solve and know whether you solved it correctly. So good job with all that. Thanks for watching. See you next time.